Okay, this is the same proof that we did in class. I just did it in a slightly different way than I did it in class. And I wanted to show you that there was another way to do it. So we're given that line M, which is this one, is parallel to line N. And we want to prove that angle 3 is congruent to angle 5. Now, I want you to notice why it's called alternate exterior angles. The angles are outside the set of parallel lines, and they're on opposite sides of the transversal, so that makes them alternate and exterior angles. So that's why they're called alternate exterior angles. And just like the proofs that we did today in class, the first thing that we start out with is the given, just like we did before. Then I wanted to look at, okay, how can I relate angle 3 to angle 5? And I kind of noticed, well, angle 3 is congruent to angle 1, and angle 1 is congruent to angle 5, so maybe I can use angle 1 as a pathway to get from angle 3 up to angle 5. So I said the measure of angle 3 is congruent to the measure of angle 1 using the vertical angles theorem. Then once I use the vertical angles theorem, then I use the corresponding angles postulate to go from angle 1 to angle 5. And since I know that these are parallel, I know that they would be congruent. And then the third step is a transitive property of congruence, where angle 3 is going to be congruent to angle 5. This is the alternate exterior angles theorem. When two parallel lines are cut by a transversal, the alternate exterior angles are congruent. And notice it has to be parallel lines. Okay, so now let's look at the alternate interior angles. The alternate interior angles would be like angle 4 and angle 6. So what they want me to do here is they want me to prove that the measure of angle 4 is congruent to the measure of angle 6, only using the things that we've already talked about. Again, the first thing I did is I stated my given, as they gave me, that M is parallel to N. After I stated my given, I again looked for a relationship between the two. One thing that I noticed was that if I looked at this, I could relate these by looking at angle 8, because angle 8 is corresponding to 4 and it's vertical to 6, so I could use angle 8 as my pathway to get from 4 to 6, so that's why I started there. I wanted to get to the other set of parallel lines, so I said that angle 4 is congruent to the 8 by the corresponding angles postulate, and then I went from there. And I said that angle 6 is congruent to 8 by the vertical angles theorem. And then I used the good old transitive property again to say that angle 4 is congruent to angle 6. Now this gives us the alternate interior angle theorem, which says if two parallel lines are cut by a transversal, the alternate interior angles will be congruent. And let's look at what they mean by alternate interior angles. They are on opposite sides of the transversal, and they're inside the parallel lines. So remember, the exterior ones were outside of the parallel lines, and they were on opposite sides of the transversal, where the interior ones are inside the parallel lines and on opposite sides of the transversal. The third theorem that they talk about in this section is the same side interior angles theorem. Now, we're not going to prove the same side interior angles theorem right now, but we could prove it, and we'll talk about how we would prove it, even though I'm not going to write it as a formal proof. But let's look at what I mean by same side supplementary angles. So that would be like angles 1 and 6. Those would be same side supplementary. And so would angles 4 and 7. Now, there is a way to do this so that it won't be too difficult to figure out. What we would do first is we would say that angle 3 is congruent to angle 4. And that would be by the linear pair theorem or the supplementary theorem. and then we would say that angle 3 is congruent to angle 7, and then we would substitute that in so that we could say that angle 4 and angle 7 are supplementary. Now, writing a proof like this takes a little bit more time, and this is one of those that I might write as a paragraph, because this would have like 6 or 7 steps in it if I had to write it. But notice, the important part of this is that these two are supplementary to each other, and these two down here are supplementary to each other. We can use this particular theorem in proofs and things that we're going to do in this chapter. Okay, if you've finished, you can remember that you can always rewind and you can go back and look at different sections of this. There are some questions that go with the assignment. The questions are out of your book. If you turn to page 273 and 274, you'll find the questions for this section. And so after you finish your notes, go and do the questions and submit them online.